All right, for part B, we're going to apply the same trick. This time, x and y are given in terms of trig functions and the parameters theta. And the point of consideration is theta equals 0. First task, we're going to find a dy over dx, and that's going to tell us the slope of the curve at theta equals 0. And I'm going to apply the same trick. I'm going to divide top and the bottom by d theta. All right, so now top represents the derivative of y with respect to theta, and the bottom represents the derivative of x with respect to theta. Here we go. I have 3 cosine theta divided by negative sine theta. And if you use the definition of cotan theta, you have negative 3 cotan theta. Okay. So this takes care of dy over dx. To find d squared y over dx squared, I'm going to make use of the Leibniz notation because this is the second derivative in Leibniz notation, which essentially means that it's the derivative of the first derivative. Okay, there we go. And for this piece here, I'm going to apply the same trick that I did above, that I am going to divide top and the bottom by d theta. So in short, this is going to be d over d theta, dy over dx, and dx over d theta. Okay? So essentially what that means is I'm going to take the derivative of dy over dx at the top, and I'm going to take the derivative of x with respect to time, with respect to theta. Here we go. You have negative 3 cotan theta, and go ahead and use the derivatives formula card to find the derivative of cotan. And that is negative 3. Well, cotan comes with the derivative of negative cosecant squared theta. So we have 3 cosecant squared theta, and then dx over d theta is already negative sine theta. Okay? And cosecant is 1 over sine theta. So 1 over sine squared theta divided by negative sine theta. If you simplify that further, you will have negative 3 divided by sine cubed theta. Okay. So now we have both dy over dx and d squared y over dx squared. So we can find the slope and the concavity at point t equals 0. So at theta equals 0, I'm sorry, not t. The parameter is theta in this problem. So here we go. So dy over dx is negative 3 cotan 0. Okay, cotan is cosine over sine, and sine 0 equals 0, and cotan 0 is undefined. Okay, what is the meaning of the slope undefined? Please think about it simultaneously, and because I'm going to graph the parametric equations and see what kind of slope, what kind of tangent line we should expect out of that. And for d squared y over dx squared, which talks about the concavity at theta equals 0, we still have negative 3 over sine cubed 0, and sine cubed 0 is 0. So for that reason, we still have undefined concavity. So now think about it. What kind of graph would have the slope to be undefined together with the concavity? All right, so let's graph the parametric equations. Have your TI-84, and in fact, you can pause the video at this moment and try graphing this, okay, and see what we have. And it should be an ellipse, okay. So let's see what it looks like. All right, this is an ellipse going with this orientation, right? We have to keep the orientation, and at theta equals 0. So at theta equals 0, I have x equals cosine 0, y equals 3 sine 0. And use your calculator and verify that x equals 1 and y equals 0. And we are right at this point, okay, on the x-axis. And if I look at the tangent line at that point, that's a vertical tangent line. And if I look at the concavity, well, there's no concavity to talk about, right? It's not concave up, not concave down, right? So at that point, the concavity is undefined. D squared y over dx squared is undefined. But we nailed that, you know, we have the dy over dx undefined. And you remember from Calc 1 that undefined slopes happen when you have a vertical tangent line, and that's exactly what is going on in this problem at the point 1 and 0. All right. So this takes care of part B, and we're done with the whole question. So thanks for watching. I'll see you in another video. Bye.